What if the next big battery didn't look like a battery at all? Imagine giant blocks quietly rising and falling inside a towering structure, not to build anything but to power everything. No wires sizzling. No chemicals degrading. Just pure motion. It might sound like something out of a sci-fi novel, but it's already happening, and in one of the last places you'd expect. While the world races to solve its energy crisis with lithium, one country is lifting an entirely different solution into the sky. There's a force we've known since childhood that's suddenly rewriting the rules of how we store power. But how does it work? And why is it spreading so fast, especially in the world's biggest energy market? Let's pull back the curtain on a game-changing technology rising, literally, above the competition. That's where a novel new energy storage technology comes to play. Vision Fund announcing that it is investing $110 million. Why are we not spending? What if the next big battery didn't look like a battery at all? Imagine giant blocks quietly rising and falling inside a towering structure, not to build anything, but to power everything. No wires sizzling, no chemicals degrading, just pure motion. It might sound like something out of a sci-fi novel, but it's already happening and in one of the last places you'd expect. While the world races to solve its energy crisis with lithium, one country is lifting an entirely different solution into the sky. There's a force we've known since childhood that's suddenly rewriting the rules of how we store power. But how does it work, and why is it spreading so fast, especially in the world's biggest energy market? Let's pull back the curtain on a game-changing technology. The competition. Gravity batteries are emerging as a powerful and sustainable solution for large-scale energy storage. Utilizing one of the most fundamental natural forces, gravity, these systems function by lifting massive weights using surplus electricity, typically generated from renewable sources like wind and solar. When energy demand increases, the weights are lowered, and the motion powers generators to release electricity back into the grid. This purely mechanical process doesn't rely on chemical reactions, making it safer, cleaner, and more environmentally sustainable than traditional battery technologies. The science behind gravity batteries is rooted in the concept of gravitational potential energy. When a heavy object is raised, it stores energy based on its height and mass. Once lowered in a controlled manner, this energy is released and transformed into electricity via regenerative motors. Gravitational potential energy does not fade with time, explains Energy Vault, emphasizing why these systems are ideal for long-duration storage. Unlike lithium-ion batteries, which degrade over cycles, gravity systems retain performance over decades, making them both cost-effective and resilient. China is the most active early adopter of gravity battery technology and has several projects underway. The facility is the first commercial utility-scale non-pumped storage system in the world, having entered the stage of full-state grid interconnection and hence ready to contribute to national energy needs. As Robert, CEO of Energy Vault, stated, "I am pleased to see the increased market adoption of Energy Vault's gravity energy storage technology in China," adding that it fits in with China's general and energy policy ambitions. Gravity storage is now rapidly scaling, with 9 ongoing EVX deployments for a total of 3.7 hours across China. Gravity storage mostly finds its success in China due to another major factor: it is adaptable and can coexist with the evolving energy policies of the nation. National laws now mandate that renewable power plants be complemented by storage systems capable of holding back output levels ranging from 20% for 2 to 4 hours. Gravity systems, because of their flexible layout and long-duration capacity, can easily accommodate this function. Andrea, CTO of Energy Vault, complimented China's local expertise and manufacturing prowess for the prompt deployment of the gravity energy storage technology at large, saying, "We have a great partner to rapidly deploy our and broader gravity energy storage technology in China." As the global energy landscape changes, gravity batteries are emerging as a scalable, policy-coherent solution to provide grid stability and reduce dependence on resource-intensive alternatives. China's EVX facility is the world's first commercial-scale gravity energy storage system, GSS, marking a significant leap in clean energy innovation. Built through a partnership between Swiss-based company Energy Vault and the Chinese government, this massive structure redefines what a battery can be. Located in Rudong, China, near a large wind farm, the facility is designed to store excess energy when production exceeds demand and release it when electricity needs to spike, ensuring stable grid performance even when renewable sources fluctuate. The EVX system operates by lifting and lowering heavy blocks to convert energy between potential and kinetic states. Each block weighs around 24 tons and is made of locally sourced materials like soil, sand, or recycled construction waste. These blocks are lifted vertically using specialized cranes during periods of energy surplus. When energy is needed, they are lowered to generate electricity using the same principle that powers pump hydro systems, but without the need for water or specific geography. What actually distinguishes this is its advanced automation and integration with the power grid. The whole structure runs under artificial intelligence and always keeps track of the energy supply and demand status. This smart system independently raises or lowers blocks as betting on grid requirements, thus maximizing efficiency. The site harvested much power at a peak of 25 megawatt, storing enough energy to supply 100 networks for hours, feeding homes during the peaks. It is projected to be over 80% round-trip efficient and last at least 35 years, making design for long-term and sustainable operation. In addition, it enjoys a significant economic edge because of its abundant local materials and minimal to no reliance on rare earth elements. The solution appears more stable, scalable, and cost-effective than current lithium-ion. It is still expensive, environmentally harmful, and quickly loses its effectiveness. China is making strides with this model by putting several hundreds of millions into EVX construction, including one exceptional 2-gigawatt construction project in Inner Mongolia. Gravity batteries versus lithium-ion. Lithium-ion batteries have been the default choice for energy storage across industries, from smartphones to electric vehicles, thanks to their compact size and high energy density. However, as global energy demand saw with the rise of EVs and AI infrastructure, their limitations are becoming harder to ignore. These batteries degrade over time, pose fire risks, and rely heavily on lithium and rare earth minerals that are both environmentally damaging and geopolitically sensitive. As noted in the interesting engineering article, extracting lithium and certain rare earth elements can be environmentally and socially damaging, and China currently controls about 72% of the lithium-ion supply chain, creating added global dependency. Gravity batteries, on the other hand, offer a durable and environmentally friendly alternative that leverage mechanical energy rather than chemical reactions. The concept is simple: excess electricity lifts heavy weights, storing energy as gravitational potential. When energy is needed, the weights are lowered to generate electricity. Unlike lithium-ion batteries, gravity systems don't degrade with use, making them ideal for long-duration and repeated applications. Plus, they're made from abundant local materials like sand, soil, and recycled waste, eliminating dependence on costly and scarce mined resources. Gravity batteries also excel for their long-term economics and costs. Their designs and operation give affordableness a different edge compared to traditional storage methods. A strong emphasis on reliability, low maintenance, and smart use of abundantly available materials makes them compelling for scalable energy storage. One prominent project in progress shows the technology can be not only cost-effective but also scalable. Picture larger deployments in the very near term. Suppose lithium-ion batteries maintain their competitive edge on small and short-term applications, solid-state for space and speed of deployment. In contrast, gravity systems would have tall buildings or deep mine shafts for vertical infrastructure, making them unsuitable for most homes or mobile applications. However, they are making strides in grid-scale storage, the scenario where large amounts of renewable energy need to be stored and dispatched efficiently. Gravity batteries have much to offer because they can produce high-capacity output while avoiding all the environmental and geopolitical problems associated with lithium. They would most likely provide a good complement to, rather than serve as an outright replacement for, lithium-ion batteries, joining with them for a more reliable and diversified worldwide energy strategy. One of the biggest challenges with renewable energy sources like solar, and wind is their inconsistency. What happens when the sun isn't shining or the wind isn't blowing? As the world pivots toward cleaner power, the demand for reliable, scalable energy storage becomes more critical than ever. Gravity energy storage offers a compelling solution by providing a way to store excess energy when generation is high and release it when demand spikes or production drops. This ability to smooth out the highs and lows of renewable energy generation could be the missing link in achieving grid stability worldwide. Gravity batteries operate on a simple yet powerful principle, converting potential energy into electricity by raising and lowering heavy weights. When there's a surplus of power, such as during a sunny or windy day, motors lift massive weights, storing the energy as gravitational potential. Later, when energy is needed, the weights are lowered, and the system converts that stored energy back into electricity using regenerative motors. Unlike chemical batteries, which degrade over time, gravity systems can be cycled repeatedly with minimal efficiency loss, making them ideal for long-duration energy storage.